Hello, this is Ashish. Today I'll be going through the analysis on citation network classification using various graph neural network architectures. So in context of citation network analysis, a graph neural network is a type of neural network designed to learn from graph structured data. It works on allowing each paper, that means a node, to gather information from the papers it cites, or it is cited, as its edges. The GNN learns a representation for the paper by combining its own features, like words or embeddings. So in this analysis, I'll be going through these different type of GNN models. So coming to the first one, the GCN model, the graph convolutional network model. To figure out the category, for example, if you take a paper A, to figure out the category of paper A, this graph convolutional network model looks at the paper A's own abstract and the abstracts of all papers it directly cites. It then takes a simple democratic average of all these features to create a new and more informed representation. And coming to the second one, graph attention network. Graph attention network is a smarter average. To classify paper A, it looks at all its neighbors, the paper it cites. But instead of averaging them equally, it uses an attention mechanism to learn that. For example, there is a paper B, which is highly relevant. For example, there is paper B, which is highly relevant. It is 90% important, whereas there is paper C, which is 10% important. So this GAT model then computes a weighted average, giving more influence to the more important names. And coming to the third one, the simple graph convolution. This simple graph convolution argues with GCNs that are too complex. It first blurs all these abstracts together by averaging neighbors with names. After this one-time blurring process, it runs a very simple and fast linear model like a logistic regression on these smooth features to predict the to predict the categories. And the next one is this approximate personalized phase rank. This model separates learning from the propagation. First, it uses a neural network to learn a powerful representation of paper A based only on its own abstract. Then it spreads this representation across citation network for many other steps, allowing paper A's information to influence other papers and other citations. And it also works in the vice versa. So before making a final and robust prediction. And the next one is multi-hop GAT model. This model assumes a single graph attention network might be too short-sighted. To classify paper A, it runs two GATs in parallel. For example, there are two hop attention network where the first hop it looks at paper A's direct citations, whereas the path two it looks at the citations of citations. That means it uses a special hop attention layer to learn whether the first hop or the second hop information is more important for the specific paper and fuses them together. And the next one is expert fusion model. This is like a committee of experts. It trains two different models, a simple optimized GNN and a complex multi-hop graph attention network. To classify paper A, it gets a prediction from both experts. A final smaller model, that means the fusion model, then looks at both outputs and make the final decision, having learned which expert to trust more and which kind of papers to classify. And the last one is Swassestin-Rubinstein model. This is like the same two expert committee model, same as the expert fusion model, but with an added, during training, it adds a penalty. The internal thinking of two experts become too different. This forces both experts to learn similar representation of each paper, making them combine knowledge more signed and making the final prediction more powerful. In this analysis, we are going to analyze two data sets. The first one is CORA. It's a well-known citation network of 2,708 scientific papers classified into seven classes. Those are case-based, genetic algorithms, neural networks, probabilistic methods, reinforcement learning, rule learning, and theory. So the inputs of this Cora dataset are 1,433 dimension binary vector. That means there are 1,433 vectors. That means words which are given a vector, which are given a binary value, whether it's present in the paper or. Based on this input, we'll train the model along with the citations that are given to a single node. Now I'll show you a demonstration of how this analysis is done. 1,433 dimension binary vector. That means there are 1,433 vectors. That means words which are given a vector, which are given a binary value, whether it's present in the paper or. Based on this input, we'll train the model along with the citations that are given to a single node. Now I'll show you a demonstration of how this analysis is.
Hello, sir. Now to begin with, we import all the essential libraries required for this project. You can see as pandas and libraries like PyTorch and PyTorch geometrics are used for building and training graph neural networks. And then coming to the second block of it, where we load the PubMed dataset using the planetoid loader from PyTorch geometric. And the dataset contains research papers as nodes and citations as edges. We also then apply normalization, which ensures all input features are scaled properly. And then coming to the hop edge function. Yeah. Then coming to the operates function, this function generates two hop edges by identifying nodes that are two steps away in the citation graph. Adding these edges allows the model to capture wider neighborhood information beyond the immediate citations. And then we can see that JNN architecture was explained from my friend Ashish. So we can move on to training and evaluation part. Now coming to the training and evaluation part, here we define a reusable training and evaluation function for any GNN model. It handles full pipeline, which includes forward pass, loss calculation, and propagation, and accuracy measurement. By generalizing the training logic into one function, we can easily test multiple architectures under the same condition. Now we can see the results section. Results. Yeah, this block represents the final performance comparison of all GNN models using accuracy, precision, recall, and FN scores on the PubMed dataset. From the accuracy, from the yeah, from the results, we observe that the APNP model, as Ashish said, that achieves the highest overall performance with an accuracy of 0.8 and the best weighted FN score of 0.7996, showing that propagation-based techniques capture long-range citation patterns effectively. GCN and GAT perform similarly, both achieving 0.7840 accuracy, showing their strong baselines for this dataset. Models like SGC and EFM and WREFM as well perform slightly lower and indicate that simplifying the graph or feature mixing reduces some structural information. Overall, this block highlights that propagation based on GNN such as APPNP and delivers the best results for knot classification on the PubMed dataset as well. And now we can come to the coming to the per class F1 score, showing that APPNP again performs strongly across all three classes, especially for class 1, where it scores almost around 0.8238. And here again, GCN and GAT also maintains balanced class-wise performance, while models like CGC and EFM shows a slightly drop in class 2. This confirms that APPNP not only achieves the highest overall accuracy, but also maintains consistent performance across all categories. And at last, coming to the graphical representation, this block of the code triggers the TSNE algorithm on learned embeddings. The TSNE algorithm reduces complex graph embeddings into 2D plot, so we can see clusters formation. This visual analysis also helps us to verify whether the model, whether the model learned meaningful patterns or not. So my friend Ashia, Taran will continue from here. Thank you.
My name is Taranjan. And beside the analysis part, we also have made the AI-powered search interference, where we use the React as a front end, Express as a backend, and we took database, PubNet database for this. And we for GNN model, we take APP-NP model as we know it perform the highest on the benchmark. And this interface make three. Now we are going to the code part. I'll explain how the flow works. First of all, like if user search, the request was going to the React app, and in the React app will open the app and and this React component take the search as an input, and this React save this as a query into a state variable using use state hook. Then user hit the enter button. The React app takes to the search query and send it to the backend. This the React app send this using fetch API to the JavaScript to the backend. Then after React app is waiting for the backend to reply, and it set a state variable like is loading is true. Then this allows you to show the loading screen on the screen, so the user knows that something is happening. So then the backend find the most similar papers and send it as a list of JSON file format. It will send the API, Hugging Face API. It will call the Hugging Face API. What it will do, it will first summarize about the content. Then after it give the most relevant citation. Then after that, it give the 10 most related research papers. Then after that, it will give it as a JSON format to the React app. Then the React app receive that JSON list and save it to the another state variable and set the loading is false. So the loading will stop, and then the React app maps this result to an array and render it as a new component. And it will show to the user. So now my friend Ashish will show how demonstrate how the app will work.
Yes, if you search something here like something like train, it will give the research paper that belongs to brain tumor, and also it will give citations to that paper, and also the recommendations after that paper not only depends on the keyword brain tumor, but also it depends on the citations that are given by the first paper. And also we have added this summarization tool where you can summarize all the paper at once. Also, we have this tool called Analyze Trends, which will analyze all the research papers given in this list, and also it will say what's happening in this field for last 1 year. For example, I'm searching the trend. As you can see, it will summarize all the trends that are happening over in the last one. And also you can categorize your search based on this 5 categories.